Good morning, grade 9s. My name is Mr. Rantene. This morning I'm going to present to you the topic exponents. Before I start with exponents, I want to put this into your attention that there are books that you have. I'm talking about the DBE workbooks. Let me just show you the DBE workbooks. I think many of you have this book. DBE workbook is book 1 and book 2. If you don't have, make sure that you get these books. They've got a whole lot of activities that you can practice mathematics. And this book, boys and girls, if you make use of it every day, practicing mathematics, you'll at the end be perfect. Its attention is on the basics of mathematics. If you want more challenging exercises, you can use your textbooks and other material. But this one, if you are really not good or not yet there with mathematics, you must use this book. It's called DBE workbook, as I've indicated. The one that I'm talking about is 11th edition. Do you get it? See here? 11th edition. Okay. Boys and girls, I'm aware most of you are coming to school maybe twice per week. Maybe this week you're coming twice, next week you're coming 3 times in a week. You've got plenty of time at home, and it's not that when you're at home you are relaxing. You have to work on your mathematics. You have to be fluent on the procedures of mathematics. You need to understand the mathematics. What I want you to do is every day make sure that when you're at home, make use of all the material that have been given to you by the teachers. Mathematics is not that difficult subject, but it needs you to work very hard, put more effort in your work. You'll see at the end, you'll understand it and you'll be happy. You know, when you understand something, there is a joy that you receive from that understanding. So now, grade 9s, I just want you to remind you, if you can see them, many of you are making the mistakes. They really don't understand some of the mathematics that is written. If I make an example, if you see I've got multiplication, 5 times 3. Multiplication, in this case, when you say this 5 times 3, it says 5 multiplied by 3, which is 5 plus 5 plus 5, which is 15. Now, many of you confuse this one with an exponent. You see here you've got 5 exponent 3. So it does not mean that you have to say 5 multiplied by 3. Here it does not say that. But here is this 5 multiplied by 3. Right? The 5 multiplied by 3, it says here 5 plus 5 plus 5 can give you 15. You can also say 3 plus 3 plus 3, 5 times, it can also give you 15. You know, multiplication is commutative. 5 times 3 is the same as 3 times 5, okay? Hence, I'm saying that. But what I wanted to bring to your attention is this one, so that when you see this, don't see that one. When you see 5 to power 3, don't think of this. Don't say just 5 times 3 when you see. It does not say that. It says that 5 is multiplied by itself 3 times. 1, 2, 3. You can see this 3 is the one that you see there up here. See that? That 3, you see here, 5 exponent 3. How many 5s do we have here? 1, 2, 3. Because there's a 3 there. Okay, you should not say 5 plus 5 plus 5. It's not the same. This is the 5 exponent 3, which is 5 multiplied by 5 multiplied by 5, which will give you 125. You must understand that. When you see something like this, don't just say 5 times 3 to give you 15. Many of you are making that mistake. I really, really don't want you to get into that mistake. Okay, so I thought that let me bring in these two examples so that you are able to differentiate what's the meaning of these two, this one and that one. Okay, now just to remind you again, I know when you are at home, you kind of you relax a lot. Ne? You sometimes forget. You don't have to forget. Here in mathematics, there are laws that one have to follow when you are dealing with exponents. But before that, before getting into the laws, let us understand the variables that we have here, or let us understand what is entailed in this exponent. When you see 2x to power 3, what is this 2 in front here of this variable x? What do we call it? We call this one a coefficient. Now just get into your textbook and check that it is there. It is. I'm just reminding you, it is called a coefficient. But this one usually is x, y, z, b. This is a variable. This variable is called a base. It is a base. Then that superscript there is called an exponent. The 3 here is an exponent. Right. But this one is a base. Then we have the 2 that we have there is the coefficient. Okay, it is there in your textbook. Any textbook has got this. Then the whole thing here, we call it a power. It's a power. Sometimes when you pronounce these things, now you say here 5 to power 3. 5 exponent 3. It's not wrong to say that. And here, because it's a 3 and a 2 has got their own special name. You can say 5 squared if you have it like this. Let me just write here. I can pronounce this one as 5 squared, 5 cube. Okay? Oh, it's not wrong to say to 5 to power 2, 5 to power 3. It is not wrong to say that. Okay? That is very important. Now, these laws, for you to understand these laws, you need to do more practice. Now, practice makes perfect. If you really want to master this section, you must have more of these things, more of this, then you master them. Then when you see them in any other question, they will see you. This one is the first law, the product of a power, of powers. In other words, the product is when you have a multiplication. Here, a product when you have a multiplication. There's a multiplication stands for the product. Here are the powers. Right? I think there's a mistake here. This should be n. Let me just correct this one. I have am multiplied by 8 to power n. Okay? That's what I have there. I think there's a mistake there. Right? So, whenever we have product of power, when we have exponents having the same base, remember what I said, the x there is the base. There can be any other variable. In this particular case, the variable that we have here is a. Here is the product of 2 exponents having the same base. Look at the base, a is a. What is the exponent of this one? A of this one is m. What is an exponent of the other one is n, as I have it here. So the law, the first law of exponency, in this particular case, I'm talking about the product of powers because I'm multiplying 2 things here. Can be more, having the same base. In this case, the base is a. What I do, I have to write that base, because it's the same. I just write it. Look at the exponent there. What do I do to the exponents? I must add the exponents, m plus n. It's just becoming so messy here. You're so used to a chalk, right? See, this law says whenever we have 2 powers of the same base, you write the base once and add the exponents. Okay, as you can see there. Now let's get to an example that I have as example number 1. First of all, we've got 2, these are the product, there's a multiplication there. Sometimes it's here they write a dot. So a dot will stand for multiplication. Don't be confused. Sometimes whenever there's an x and this one, you just get confused. You see the next exercise there. Some might get confused. So here, what I want you to know is this multiplication sign can be replaced by a dot. It means the same thing. Here, let's see how we can apply this law. Look at this law. It says that if I've got 2 and not even 2 exponent of the same base, multiplying exponent of the same base, what do? You add the exponent. Here the exponents, m and n, you added them together. Now let's try to apply this rule here. Are we having the same base? Yes. The base is 2 here, the base 2 here. What are we doing? You are multiplying them. Oh, if you are multiplying them, what are you going to do? We are going to add the exponents. So what do? You write the base once. The base is 2. I've written it once. You can see there. What must I do to the exponents? I must add the exponents. 3 plus 2 equals to 2 to power 5. Okay? We have applied this law. Ne? Product of powers. You have already applied them when you have done this. You can, because it's a number, you can simplify it. Ne? You can simplify it by saying 2 multiplied by 2 multiplied by 2. How many times? 5 times. Ne? Like I have done with this example. Ne? It's the same as this example. Okay? This one here. You see, how many times does 5 appear here? This power says you must have 5 appearing 3 times. Here, it says that you must have 2 appearing how many times? 5 times. It's 2 multiplied by 2, multiplied by 2, multiplied by 2, multiplied by 2. How many 2's? 1, 2, 3, 4, 5. There are 5. Yeah? Then you can just get the answer. What will be the answer? 2 times 2 is 4. 4 times 2, 8. 8 times 2 is 16. 16 times 2 is 32. That's the answer. Okay? This is how you do this one. Now, another example based on this law, this law, product of powers, multiplying powers of the same base, you add the exponent. Let's see here. Let's see this one now, how it works. Right? Here is x squared multiplied by x cubed. You can even say x to the power 2 multiplied by x to the power 3. What will be your answer? Are we having the same basis? Yes, the same basis, x and x. Okay? When you multiply exponent of the same basis or powers of the same basis, what do you do to the exponents? You add the exponents. What is this? What is the base here? Is x. So you write your x once. What do you do to the exponent? You must add is 2 plus 3. Then this will be equals to x exponent 5. Okay? This is how you apply this law, right? Now, if you look at, there are other examples, a lot of examples that you can do to apply this law. Ne? For instance, if you look at the DBE workbook, ne, on page 22, ne, it's actually page 56. Let's look at what is in page 56. When I'm talking 56, I am referring here to this one. Ne? This 56. Look at here. We have, for an example, a cubed multiplied by a to the power 4. Ne? Well, a to the power 3 multiplied by a to the power 4. Ne? It's the same law. You can even see up there. It's the same law that we have started with. Ne? What do you do when you're multiplying powers of the same base? You add the exponent. What will be the answer here? I know you have your DBE workbooks. You are on this page. And what will be the answer? What do you do to the bases? You write the base only once. Ne? You can even write it here because this one is mine. You can say A here. Because A, the base here is A. I'm writing it once. What must I do to the exponents? I'll add the exponents. What are the exponents? It will be 3 plus 4. Right? This will give me a to the power 7. Okay? You see, there are lots and lots of these activities that you can do for you to able to master this law. Okay? Remember, when you get deeper these laws will be combined. You must be able to identify the law, to say this one is that law, the product of powers, this one is what, this one is what. So we are going to learn all the laws so that we are able to apply them in one exercise. Okay. Right. As you can see, there are lots and lots of activities that you can do to master that law. Ne? It's a lot of them. Okay. Right. Now I also have other activities except what I have brought to you there. I have this this activity. I mean, this is the worksheet. Right, this worksheet, boys and girls, you can see I've downloaded it from the Kuta software. I've downloaded it, also given to your teachers. If your teachers don't have it, they must get it from their subject advisors. These are a lot and lot of worksheets that you can use to practice. Right? Let's see here now. It's the same law that we have done. Look at this one. I said to you, when you see a dot, you must know it's multiplication. You are multiplying here powers of the same base. What's the base here is 4, né? Right? What are the exponents here? Exponents for this one is 2, for this one is 2. So what do? You know how to apply it. What you will write the base at once as 4 here. Then what will I do to the exponents? I must just add the exponent. 2 plus 2 is 4. Né? Because these are numbers, you must be able to simplify them. Okay? Please remember that if you look at number 2 here, I know you can just use the calculator to get the answer there. If you see just a number, you must know it is raised to power 1. Even when you have x, just x, you must know it is raised to exponent 1. Okay? Don't be confused by that. Some of you might think that no, it's something else. Still, this is 4 to power 1, this is 4 to power 2. Same base. What you do, you write the base once, then you add the exponents. Then you will be able to simplify. In this particular case, you can see it will be 4 to power 3. Right? Then you can simplify it further. Right? Same law. Same law. Same base here. It's fine. You can do it. Same base. But remember there, power is 1. Then you can work it out. There are how many of them? 3. This is raised to power 1, raised to power 2 to power 2. Right? What do? You write the base at once. What do you do to the exponent? You must just add. How many are they? You've got 1 here, 2 there, 2 there. So when you add them, it will give you 2 to power 5. Okay? Right. Then this one, what's the base? The base is 3. It's the same. What do you do the exponent? Just add them, it will give you 4. You can simplify further with your calculator, or you can just say 3 times 3 times 3, 4. It must appear 4 times. Then you get your answer. Right. This one is a little bit, you'll see that you've got coefficients now on the number 5 here. You've got 2 n to power 4 multiplied by 5 n to power 4. Right? You can see the variable. What are the variables here? What's the base here? The base here is just sorry, I forgot to switch off the phone. My apologies, boys and girls. Right. When you get to the number 5 here, you will see that is 2 n to power 4. The 2 is the coefficient. N here is the base, the 4 is an exponent. Multiplied by 5 is the coefficient, n is the base, we've got exponent 4 here. Now, when you have such exercises or such activity or question, or where you are asked to simplify, in this case, multiply these coefficients, all the coefficients together. What are the coefficients that I have? I've got 2 here, then I have 5 here. So 2 multiplied by 5, it will give you what? 10. It will give you 10. Right. When you get to n now, you see that n here, n to power 4, you've got n to power 4 here. What do you do? Because you're having the powers of the same base. What's the base? The base is n. What do? You write the base once. What do you do to exponents? 4 plus 4, you just add them. It will give you 8. Okay? So when you multiply 2 to power n, multiply by, 2 multiplied by n to power 4, multiply by 5 n to power 4, it will give you 10 n to power 8. Okay? It is very important that take care of the coefficients, multiply the coefficients together. Right? Then this, I will also want to do this one. Let's get to this one. The coefficient is 6 here, the coefficient here is 5. We've got r here, r to power what? 1. For you not to be confused, I just write that 1 there so that you are able to know what's going on. There was no 1, but I have written the 1 there because if you have just a letter or a number, it's raised to power 1. Okay? Right? You see, what's the base here? The base that I have is r and r. Remember what I said? The base cannot be only x every time x. No, it changes. As you can see, this worksheet, it has got different bases. The variables are different. In this case, we got the r, but this one we had n. All right. Now, if you multiply 6 by 5, it will give you 30. 30. Then you've got r to power 1 here. If you multiply by r to power 2, you've got powers of the same base. The base is r. You write the base once. There's the base. Then what you do to the exponents? You add them. 1 plus 2 is 3. Okay? You see? How is? But if you do more of this, practice make perfect, more of this, you'll at the end be able to master the product of powers or the laws of exponents, right? The last one here, as you can see here, I'm not going to do all of them here. You'll actually practice when you watch this video. You'll practice the rest that I've shown you here. Then this one, the coefficient here is 6. Coefficient for this one is 2. Then here, remember what I said, if you don't see an exponent, in this case, you must know it's 1. You must just write it for the sake, for you to be able to, not to make a mistake. Because some of you, because there's nothing written here, you tend to leave it out. So it's important that you must write it. Right? Here, 6 multiplied by 2, it will give you 12. Here, are we having the same basis? Yes, the same basis, which are x. Then you write your base once. What you do to exponent, you add 1 plus 2 is 3. Okay? This is how you do it. I'm not going to do all of this. Of course, there's plenty. What I want to do now is to move to the next law. The next law right, before the next law, I think I also need to get to this example. I feel that it's important. Sometimes we might have brackets. Brackets are involved here. Whenever you've got the brackets in this fashion, you must notice the multiplication. It's multiplication. This one is multiplied with that. In other words, the whole thing here is multiplied with the whole of that one. It's not separate. Because if you remove this bracket, there's going to be a confusion. It's going to be a lot of confusion. So some of you might not see the confusion, but some will. So it's better that to use these brackets, so just to distinguish between what we have here and what we have there. Right? Now, this thing, what is written here, which is 2x squared multiplied by 3x to power 4. That's what it says. It can be written as 2x squared. I can put a dot here so that you don't make a mistake. Multiply by 3x to power 4. It's the same as what I have here. It is the same as what I have here. Sometimes if I can put an x here, it might create some confusion for some learners. So a dot is preferred when you have the x's here. But you can use the x when you have maybe a different variable from x. Because some people would write their x. You write your x like this, which is almost the same as multiplication, you see. That's why I prefer that when you have write an x this way, you can use a dot just for multiplication, and it looks much better. Okay? Even though some you can see, some of you can even see that x multiplied by, it can also be seen like that. you can see if you have written this way, it's better. Ne? But as I said, it's preferred that you use this one so that no confusion is created. Right, now let's do this one. Ne? You can even do that one, it's okay, it's the same thing. Then here we've got coefficients, then let's multiply coefficients together. This will give you 6. Then where are the powers? We've got x to power 2, x to power 4, or x exponent 2, x exponent 4. It does not matter how you pronounce them or how you name them. Right, because we've got the same base here, right, what do you do? You write the base at once, yes, once. Then what you do to those exponents, you must just add them. 6. This is your answer. Okay? Right. Now let's get to the next law. It says the power of power. Yeah? The power of power. Right. Why do I say power of power? This is the power. Ne? If I close this m, the n here, you can see what I have there. I'll have a to power m. Ne? I have closed it. Okay. So why is power of power? It's the power already raised to a power n. Ne? In other words, we've got a exponent m, all raised to exponent n. Okay. When we have something like this, power of power, when you simplify it, it's the same as a m n. In other words, only multiply this exponent together to get your answer. Just multiply this exponent together to get an answer. Right? What's the meaning of what I have here? Let me just make an example with this one. I've got x squared all to power 3. It means what is in the bracket here is multiplied by itself 3 times. There's a 3 here. Yeah? But what is inside here, which is x, is multiplied by itself 2 times. Yeah? Okay? You'll see when you just simplify. Then what do we have here? I'm trying to understand what will be the answer of this one. When you apply the law, it says that x exponent 2 all to exponent 3, you just multiply this exponent to get the answer. In other words, the answer of this would be x to the power 6. Eh? You don't add. You don't add. Don't confuse it with the product of power, the one that you did in the beginning. Eh? This one is the power of power. An exponent that is raised to another exponent. Like in this case, you've got x squared raised to cubed. Eh? So its meaning, it says what is in the bracket is multiplied by itself 3 times, as you can see here. Right? That's the meaning of that. What will be the answer then? You can apply the law, the first law of exponents. You can say, okay, let's see. The first law of exponent, the one that I did now, the product of power, it will be the same. How many, what are the bases here? The basis is x, x, x. Né? You see, the base is x, I can write it once. What are the exponents? Yeah, 2 there, 2 there, 2 there. I must just add them. 2 plus 2 plus 2 is 6. Okay? You can see that this thing is the same. It's the same as 2 multiplied by 3 is 6. It's shorter. Né? When you see something like this, you just multiply this exponent together to get your answer. But don't change the base. Base must still stay the same. Okay? Right, if you simplify it further, say for instance you want to expand this, you can say no, okay, this is x multiplied by x, né? X multiplied by x, right? X multiplied by x. How many times? There should be 6. Né? Here you've got, this one is x multiplied by x, this one x multiplied by x, that one x multiplied by. Right, how many x's that we have here? Remember there's a 1 here, né? You must always say when you work with exponents, because for you not to be confused, because some of you might be doing these exponents for the first time, or they might have forgotten, just write there. Then same base, all of them is x. What are the exponents? You must add exponents 1, 2, 3, 4, 5, 6, it's 6. No, it's still the same, see? Still the same. So it means that when you have power of power, it's shorter, it's quicker just to multiply this together. But here I was just showing you how this came about. It confirms what I have there, that you multiply, when you have powers of powers, then you multiply the exponents together to get your answer. Right, let me just see if I can get an example here, another example from the worksheets that we have, where you are going to apply the power of power. You don't have to be don't be scared. It's easy to apply. Right, let's see here. Ne? Let's see this example. Number 1. Ne? You see I have something here, it represents the power of power. Ne? I have something in, let me take for an example number 11. Ne? Yes, number 11. Ne? Even number 9. Let's start with number 9. Right, here we've got x squared, y squared, all raised to power 2. Ne? This is the power raised to another power. So it's the power of power here. Ne? Remember what is the law says. It says that you must just multiply only the exponents together. So it means you must write the bases once. In this case, what is the base for this one is x. Ne? What you do to the exponent is 2 multiplied by 2 to give you 4. Then you get to another variable. Ne? Even if you got many variables, you must go through all of them must multiply by that 2 that is outside. Ne? Then you've got y. 2 multiplied by 2 to give you 4. Okay? This is the answer for it. This is the power of power. Let me get to number 11. Right, number 11. You've got y to power 4, or u to power 4, v to power 3, all to power 2. Okay? Now, the law that I've done of power, it says the exponents must be multiplied together. You say u, then to be 4 multiplied by 2 to give you 8. Then you've got v, 3 multiplied by 2 to give you 6. Okay? This is how you do it. Let me take you to the one that you always, most of the time, you guys, you make mistakes. But if you can practice this worksheet, you'll remember that everything should be distributed, multiplied by the 2 that is outside here. Everything that is here. Here, you see, everything that was here was multiplied by 2. Okay? Let me take you to the one that where you make mistake. Most of the time, you guys, you make these mistakes. I don't know, when you write mathematics, you must be serious. You must be serious. You must take your things serious. You should not just say, oh, that mathematics. No, it will take you further, and you can get a better result by merely practicing mathematics every day, and you practice everything. This thing, you see almost the same thing. Then you will understand it. Right? Let's see this one. What is the rule saying? It says the 3 must be multiplied with everything that is inside. For number 1 there. It says that the 3 must be distributed, multiplied by all the powers that are there. Remember what I said. Whenever you don't see a power, you must write it. In this case, there's the 3. It will be 3 to the power 1. I'll put it there. So that you don't forget to multiply with what you see outside this bracket. Okay? Then what will be the answer when you simplify? It will say it will be 3. What do you do with the exponent? You multiply then 3 multiplied by 3. Don't add. Don't go to addition. It's not that one. Okay? It's not that rule or that law. So it will be 3 times 1 is 3. Okay? What's next? It's the a now. A squared, all raised to this one. Therefore, what do? You write the a. Okay? 2 multiplied by 3, 6. Okay? Then you can simplify this one because you can still do it. 3 to the power 3 is 27. A to the power 6. Okay? This is the answer for this one. You see, I have written the one deliberately because you guys, some of you made a mistake. You just leave this 3 as it is. You don't multiply with the 3 that we have outside there. So you must distribute it. This multiplied by that, this multiplied by that. This is what I have done. You also have to do it that way. Let me do the similar one that we have here. Right, you don't see, there's no exponent on 2 there. Then I can write that one and put it there. Right? Nothing wrong with that. Nothing wrong with that. Then I'll have, write the 2, then I just multiply the exponent. 4 times 1 is 4. Then write the n. 4 times 4 is 16. Then you can simplify this one. I think it give you 16. And the power 16. Right? You see how important it is to write the 4, because you are able to see that I have to multiply with the 4 that I have outside there. Right? Let's get to the other one that is a bit... Let's see. Let's get to number 18. Now I'm challenging you now. Ne? You start with the simplest one, then you get deeper. So long as you understand the rules or the law, then you won't go wrong. Ne? Number 18. Look at what you have, number 18. Ne? Why are they doing it? They're saying that this 4n to power 4, you multiply with n. You must know the n here, there's a 1 there. Ne? There's a 1 as an exponent. Ne? Right. So it says here, you can apply the first law that we have done, product of power. Then if you apply that law, it will be 4. 4 is multiplied with, we've got the 1 there, so it will be 4. Then we've got n to power 4, n to power 1. This is the powers of the same base. Ne? You write the base once. Ne? You add the exponent is 5. Ne? Don't forget, this is all raised to power 2. Okay? Then we are back to our rule now. We are back to our rule. Power of power. We are back to our rule. Remember that here, the 4 here is to power 1. Okay? I'm writing it. Then now we can multiply. Now we get to that thing of multiplying the power of the exponents together. Now we've got 4 here, write it once. 2 times 1 is 2. Then we've got to n now. Ne? 5 times 2 is 10. Ne? Right? Then you can simplify this further. 4 to power 2 is 16, and to power 10. This is the answer. Okay? This is your answer. What it just says here, that is just apply that rule, the first rule. Ne? But even if you don't apply it, you can still get it, but it's preferred when they do it this way, that apply the rule so that you can make it easier when it gets here. Here, apply the rule, thereafter you apply the second. In other words, you've got 2 rules that are applied here. Product of power and the power of power that I've just done now. Okay? That's what's going to happen. They are not only to ask you a question that is straightforward like this. You might get a question that is straightforward, maybe like this one. Ne? But when you get deeper into exponent, you're exposed to this type of questions, ne? Where the combinations of law have been applied. Okay? Right, this is about power of power. Right, now let's get to another law where we've got a product. Here is the product. 2 things are multiplied together, raised to an exponent. Like, if I have this, something like this, the product of power. 2 things are multiplied together, raised to a certain power. This is what we are going to do. Right. What is the law saying? It says that here, it's almost similar what we have here, ne? What we did here. In fact, the example that we have done here is most applicable as well to this rule that I'm talking about here, where this is distributed in the power of product. It means what I have here is multiplied with that one. There's a 1 here, m multiplied by 1, a to power m. B, there's a 1 up here, m multiplied by 1 is b to power n. Okay, this is the law. Almost similar to that, but this one has got only 1 variable, only 1 here, power here, power. But here you've got a product, which are those examples that I've just done. You're almost a step ahead, right? We can actually apply it. In this case, there's only 1 here. There's a 1 here for this example. Remember what I said? It will be distributed. It's x, 3 multiplied by 1 is 3. It's 3. Then also 3 distributed to y to power 3. Okay, this is exactly what we have done. Those are examples that we have done there. These ones. These examples, what I've done there, are applicable to this law, power of product. Here's a product to a power. Power of product. Okay? Here is just a power to a power. Okay, but here you've got the product. So as the same as the example that I've done, and many examples I've done on this one. Right, example number 6, I have done that. Let me put the 3 here. Let me put the 3 there. It's the same. We've done most of the exercises on this one. I can quickly do this one for you, and of course, you will be able to do it. As I said, your DBE workbooks have got plenty of exercises for you to practice, for you to be able to be perfect in exponents, because exponents are most applicable in algebra, and you are not going to be told apply this law, apply this law. You have to actually recognize which law you have to apply there. Okay, right? As I said here, in this case, is a power of product. You see, 2 is multiplied by x squared. It's also multiplied by y to power 3. Yeah? All raised to power 3. So here, very important, because I don't see an exponent on the 2. I must just write it. I must know it's 1. I must put it there. Very, very important. I want you to do that one, especially if you are not yet perfect on exponents. Then what I do is, what you have in here, you write it once. There's a 2. 3 multiplied by 1, you get a 3. Yeah? The next one is x. Then 3 multiplied by that 2 is 6. The next one is y. Then 3 multiplied by 3 is 9. Okay. Then you've got 2 to exponent 3. It would give you 8. Then x to the power 6, y to the power 9. Okay. So this is the answer of this exercise. Don't forget, you distribute everything that is in the bracket. The powers must be multiplied with. Don't just run and multiply it and make it 6. No, I'm talking about exponent. That is why I have written 1 here. That is why I have written 1 there, so that you are able to say that I'm multiplying the exponents with the exponent outside the bracket, leaving out what I have here. You see, there's 2 here. I've written it here. X is still here. Y is still here. But what I've done, I have multiplied the exponents. As I said, when you don't see an exponent, you must know it's 1. All right? Right. There's another example. When you get deeper into mathematics where exponents are involved, you see here, its product is also this law, né? Power of product. Here's a product. 2 times 3. It's a product. Yeah? I know it would give you 6. Yeah? There's a 6. The 6 is raised to the power 3, which is give you how much? 260. Okay? It's easy. It's numbers. You can quickly work it out. If you apply a law, if I apply this law, it says that everything that is here is multiplied by 2. Let's see, multiplied by this 3. So it means I must write the ones, the 1 there, so that I know what I'm doing there. It's 3 multiplied by 1, it will give me a 3 here. For 3 multiplied by this one is a 3, which means the 2 to the power 3, it will give you 8, multiplied by 3 to the power 3 is 27. When you multiply this together, it will give you this one. And it's also the same. Okay? There will be instances where you have to break the 6 in trying to get somewhere. So I was just saying to you, this law, power of products, is also applicable on the numbers here, if you want to simplify it. Yes. Then the next one, the next law that we are going to look at, boys and girls, I know wherever you are now saying, hey, it's a lot. No, you must do a lot. For when you do mathematics, a lot of activities must be done for you to be able to succeed. I'm trying to get to a page in DBE workbooks where some of these laws are applied. Some of these laws are applied. I can see now here they have moved further. They have moved further. I just want you to look at this one. Yeah? Simplify number 1 there. It says, this is the product, yeah? Raised to 5. It's a product of power. Okay? Here, it's a product. You multiply raised to 5. What do you say here? What did I say? When you have something like this, you must write, you must put the 1 there because you don't see them. Okay? This is multiplication, it's the product. I did not talk about the sum of this to raise to. I did not say something like that. Don't go there. Don't try when you see a plus here and try to apply this law. No, it is not applicable here. Here I'm talking about product of powers, right? Now, how am I going to do this? I'm going to write my B here. 1 multiplied by 5 is 5. Then I've got the C to power 1 here. Then I'm going to write the C. 5 multiplied by 1 is 5. See? Right. You see how this is done? I'm applying the law. I'm also going to apply the law here, because I know what I've done here. Now the R is going to be R to the power 5, S to the power 5. Okay? I'm applying the law. By saying I'm distributing, I'm multiplying this one. Remember, it's 1 there. There's a 1 here. I always say write it so that you're able to see what you multiply in there. Because some of you when you don't see a 1 here, then you say there's nothing there. Like you usually do when the coefficient is not multiplied. The exponent of a coefficient is not multiplied with that exponent outside the bracket. Right. Right. I was just indicating to you that there's a lot of activities that you can do. I want to see when I get to your school. When I get to your school, I want to see these pages full. You have practiced because you've got plenty of time at home. I want to see this full. The pages here. When you have completed an activity, if you're a teacher, go to this book and complete all these activities that are here. This book must be full when I arrive at your school. Right. We are getting closer. I just want you to let us get to now another law, quotient of powers. In other words, we are now dividing the powers. We are dividing the exponents. In this case, you see 8 to the power m divided by 8 to the power n. We've got the same base a. Yes, it has been written once, but what you do is you subtract the exponents. We must also see that the one that we did, the first law, it was multiplication. What we did, we have written the base ones and added. But here, because we are dividing, dividing powers of the same base. Sorry. We are dividing the powers of the same base, a. What you do to the exponent, you subtract the exponent. You write a once, subtract the exponent. That's what the law is saying. Right? Look at this example. What is the base? X. If it was y there, you cannot apply the law where the exponents have got a different base. You don't have to apply that law. If I had x here, it's x here and y here. The bases are not the same. You can't do anything with that one. You cannot do anything with it. But here, because the bases are the same, you apply the law. The law says you write the base 1 and subtract the exponents. In this case, 7 minus 3. You see here, m minus n. It's not 3 minus 7. It's the one numerator, the exponent of the numerator, minus the exponent of a denominator. In this particular case, you can see that. I did not say 3 minus 9, but I said 7 minus 3. The answer there is 4, which is x to the power 4. I have applied the law because I know what the law is saying. If you don't know the law, how would you apply the law that you don't know? In this case, I make sure that I know this law. Then you'll be able to see. Here I have, because they're dividing parts of the same base, I must apply the law. It says I must subtract the exponent. It's exactly that. Hence, you must know these laws. Textbooks are there. I've got all these laws. DBE workbooks have got all these laws. Any other mathematical material, being a worksheet, being a textbook, has got these laws that you must know. and be able to apply. Here is just an example that indicates how did you get to this one. Say if you have to expand it, you see there how many x to power 7, what does it say? It says x is multiplied by itself 7 times. 1, 2, 3, 4, 5, 6, 7. Okay, that's what it's done. The dot is multiplying. Then when you get to 3 here, is x multiplied by itself how many times? 3 times. 1, 2, 3. Itself. As you can see, x, x, x. Now, here you can just cancel out the x's or divide. Then what will be remaining here is how many x's? 4 of them. X multiplied by x multiplied by x. Same base, apply the first law. What do you do, exponents? Because you can't see, it's not written, you must know it's 1, 1. How many are they? There are 4, hence you have it there. I was just showing you in a different way. If you find this one, but you must know the law. The law is a shortcut. You can't be working with this type of situation. If you have 20, you are going to have something, all the x's that are 20 there. If you've got 40 here, the x's should be 40. You see now it's going to, your page is going to be messy. I don't want something like that. So because you know the law, just quickly do it this way. Imagine having all of this just for only 2 marks. Canceling there, sometimes you make a mistake. Hence, you must know the law. An example. There's an example. I've got 5x cubed divided by 10x. Here I've got the variable, another variable. That I can work it out. If it's divisible, then I can do it. 5 into 5, 1 time. 5 into 10, 2 times. Okay? I'm done with the variables. Now I'm getting. Now I'm done with the coefficient. Now I'm getting to the variables. What are the variables? The variables is x. Okay? I'm dividing x cubed by x. Same base, which is x. I'm going to write it once. Right? What do I do? Because I'm dividing, I'm subtracting the exponent. I don't see an exponent there. Now I must write it. Then I'm going to subtract it. It will be 3 minus 1. Finally, it's going to be half x to power 2. So the coefficients, if they are divisible, just divide them out. Simplify them, like I did here. But if it was 3 here, I'm going to leave it as it is because it's not divisible. If it was 3 here, 12 here, yes, it's divisible, I can simplify it. Okay? That's it. Right, boys and girls, let me locate one example that will address this example of quotient of a power. If you look at number 21, let's look at number 21. It says r squared divided by 2r to power 3. Okay? Now, same law can be applied. We're applying the same law, right? It says, here I've got the 1 here, I've got the 2 here. Remember, it's 1r squared. When you don't see a number here, you must know always in the variable. If you get a variable, what is in front of a variable, if it's not written, you must know it's 1. So in this case, the numerator, I still have a 1. I can write 1 there, it's not a problem. Then here, it's not divisible, I can keep my 2 there. But now I can see that here, the bases are the same, which is r. What do you do when you divide the bases of the same, the powers of the same base? You write the base once, use the r. Did not confuse this now. This one is all about the coefficient. You write the r. What do you do to the exponent? You subtract the exponent. You subtract the exponent of the numerator. You say the exponent of the numerator multiply the exponent of the denominator. Don't just run to say, oh, 3 is bigger than 2, and therefore you say 3 minus 2. Oh, no, my friend, it's wrong. It should be 2 subtract 3. Ooh, we are in trouble if you don't know how to do subtraction of integers. Yeah? You are in trouble. You see now the importance of you understanding the integers. Yeah? Here I'm subtracting a bigger number from a smaller one. Yeah? In this case, that will be half r minus 1. Yeah? Okay? Remember, we have not yet come to this one. Yeah? We can leave it as it is as an answer. I did not say 3 minus 2. I just said 2 minus 3. I got minus 1. That's the answer. Don't get there. Don't be tempted to say 3 minus 2. Something that make it easy for you. No. No, Buddha. Sister. I say it usual. Doesn't work like that. You subtract the exponent, the numerator minus the exponent of a denominator. That's exactly that. That's when you apply the law. Right, now let's distribute the power of a quotient. Here's the quotient, a divided by b, all raised to m. The law says you must distribute this power to all the numerator and the denominator. This is exactly what is done here. It has been distributed. Remember, there's a 1 there, there's a 1 there. I always say when you don't see a power or exponent, it's a 1. Right? Here is this law. Let's try to apply the law. The 4 here belong to the numerator, also belong to numerator, to denominator. So you must distribute it. So it will be x. I'm talking about the numerator. X multiplying the 4 here with this exponent is 8. Now I'm going to the denominator, it's y. Multiplying the 4 with the 3, it will give you 12. Okay? That's the answer of this one. You see, I have distributed the 4. Whatever is in the numerator, whether you have a lot of the product of something, the 4 is distributed to all what is in the numerator. The powers, you don't just multiply with the coefficient. All the powers or the exponents of a numerator. You'll see when I give you another example where you've got a lot of numbers on the numerator and the denominator as well. This is just an easy one. Let me look at an example that will address what I'm talking about here. Right, say, let me write example here, another example. Let's say I've got this example now. Just trying to, let's say 4xy squared over, say 2x squared y, all raised to power 2. This is the power of quotient. There's a quotient. But now, as I said, the 2 is distributed in the numerator, 2 is distributed with the denominator. Okay. Now what I do, because I don't see the exponent of the 4, I'm going to write 1 there. I don't see exponents of this y, x here, I'm going to write 1 there. And I don't see here, I'm going to write the 1 there. Don't be confused. I'm just writing it for the purpose of me seeing what is it that I'm multiplying with. Here, I'm going to distribute it here. I'm going to write 4. 2 multiplied by 1 is 2. Then I have x here to power 1. 2 multiplied by 1 is x. 2 there. Then I've got the y. 2 multiplied by 2 is 4. Then I just write this is my denominator. Now I'm focusing on the denominator here. Then I've got 2 here. 1 multiplied by 2 is 2. Then I've got x. 2 multiplied by 2 is 4. Then I've got y. No, y is to power 1. Then I've got y. 1 multiplied by 2 is 2. Right? You see how this thing looks like. But can it be further simplified? Yes, you can apply a law here. can apply the rule again here. Here I've got this number. This is 16 x to the power 2 y to the power 4 divided by 4 here. I can just simplify it, x to the power this, y to the power 2. But if I further simplify it, boys and girls, it will go like this. Let me further simplify it. Right, 16 divided by 4 definitely is going to give you 4. Yeah. Right. Then x squared divided by x to the power 4. Which law am I applying? Quotient of power. Yeah. Dividing powers of the same base. The base here is x. So I'm going to write my x once. What do? Subtract the exponent. Just subtract the exponent. Use the numerator exponent, subtract the denominator exponent, which is 2 subtract 4. Right? Then I get to y now. Same base, y, I write it once, 4 subtract 2. Simplify further, 4 x power minus 2. Then we got y squared. Okay. Right. You will see that when you get to this law, there's a law that we are coming to now after this one. I think it will be easy. I think it's the next one. So what you can do is, one have to know that any number to power 0 is 1. Yeah? Let's say, for instance, you divide x squared divided by x squared. What's an answer? It's 1. Yeah? Let's apply the law. It will be x 2 minus 2 equals to x to the power 0, yeah? Which means x to the power 0 is 1. Okay? Then also, if you have x to the power negative 1 is the same as 1 over x. That you must know. As when you write it as positive, when you get to this one, I'll show you right now. Then x to the power negative 1 equals to 1 over 2, 1 over x. Yeah? If you have x to the power negative 4, it's the same as 1 over x positive 4. Right? If we have this one, look at what it is now. Eh? If you have this one, you must know is, now I'm trying to, let me just see. No, it can be. Right, if you have this one, or 8, sorry, let me just write it nicely here. Sorry guys, I don't want to confuse you. Let me not get there. What I'm trying to say here, when you write this one to a positive, we need to write it this way. Yeah? In other words, if I have to simplify this, I'm not going to get into it, I don't want to get you confused. Yeah? If you simplify this one, it will be 4y squared over x squared. I do not want to get to this one. I can simplify it, but I don't want you to get confused because I want you to understand this one. So if you've got a negative, you must just make it it's in the numerator, make it's positive when it becomes a denominator. If it was negative here, it will be positive that side. That's what I mean. Yeah? So it means if I have something like this here, it will end up here. Yeah? Yes. That's what I was trying to explain there. This one will end up there, right? Okay, I think what we have done here in terms of the laws, I want us to do. We are just about to finish what we have done with the exponents. What is important, boys and girls, is the application of the combination of these laws. Combine them together. As you can see here, That's the main thing that one have to know, that at the end you will see something like this. That is asked to you. Now, I can see there's this line. It says everything that is on top here is divided by what is here. What I'll do is I'll leave this one for a while and simplify what is up there. Thereafter, then I can apply my my loss. Okay. Now let's see. Let's see. I'm going to write this somewhere here. Let's see what we have here. I'm multiplying here. That's the first law. The multiplication is involved here. I've got x here. I've got x here. Now, so it means bases are the same here. I can do something when I multiply. I'll add the exponent. I've got another base here, y. There's another y. Then they are multiplying them together. No, it means I'll do something about the exponent. Then I've got the coefficient 3 here. I can multiply with this 4 here. What will it give me? If I multiply 3 by 4, it will give me 12. Okay. I'm talking about now the numerator. There's my division line. What else now? I must get to x. X cubed multiplied by x to the power 10. Then I'm going to write my x once. What must I do with the exponents? I must add the exponent. 10 plus 3 is 13. Okay. Now what is left? The y. Y to the power 3 multiplied by y to the power 5 multiplied by y to the power 3. What is it? We are multiplying the powers of the same base, which is y. I write the y once. I must add the exponents. 5 plus 2 is 7. Then I can write my denominator now, because I have already simplified my numerator. I can write my denominator. Right? Right. Let me now simplify. If you simplify this further, what is it that get in here and there without leaving any denominator, remainder? You can start simple, to say, let's say 2 here. 2 here. 2 goes into 12 6 times. Just do this. 2 goes here. How many times? It's 15. Right. Okay. I'm just making an example. You can go. You see that still this is divisible. But I was just trying to say, if you really don't know your LCMs, then it will become. You can start very low until you get it, but it's going to be messy. You must know them. Now let me get to the x's. X to the power 13 when divided by x to the power 14. Write the base ones. X 13 subtract 14. Right? Then you get to y. Then y would be y 7 subtract 6. Right? Further, 3 here 2 times. 3 here 5 times. Now I can just extend it. This one will be x to the power -1, y to the power 1. Then remember, I only want the positive exponents. Then I'll have here the 2y. Then this one become positive. It will go down to the denominator, become positive. This is the answer for that. Okay. Right, boys and girls. This is exactly what we have here. But what I really want you to get into, I always refer to this book because it has got plenty of exercises for you to do. Now, there is an exercise that I would want us to look at. Let's see here. It's simple, can be done. Let me write it on the clean sheet of paper. I'm referring to this one, number A. Look at what it says. X squared divided by x to the power 3 all divided by x to the power 4. Yeah? Right? Let me remove the book. Okay. Right. Now here, I first have to apply the rule. Dividing parts of the same base, what do you do to the exponent? You subtract the exponent. So it will be here is x to subtract 3 divided by x power 4. You see now we are simplifying it further. Then this one will be x negative 1 divided by x negative 4. Right? Right. This can also be further divided. Then it will be, you are dividing parts of the same base, you subtract the exponent. Don't be scared, because when you see negative, then you become negative 1 minus 4. Then the answer will give you x to the power negative 5. Right? Then it's written as positive exponent 1 over x to the power 5. Right? This is the answer of that. When you write as positive exponent. See how easy it was. I apply the rule here, and again I apply the same rule here, then to get to this answer. Right? Let me just see again the exercises that you can do. As I said, you must request your teacher to give you these worksheets for you to go through. There's plenty of them. I want us to look at number 26. 26 is written as the 26 is written as 2x to the power 4, y negative 4, z negative 3. Yeah? If you're really not okay with the integers, you really need to make sure that you can add and subtract or multiply numbers having different signs. Right. Simplify this one. I can see the coefficients here. There's nothing that you can simplify with this one. The 2 here and the 3 here. Cannot simplify them. So what I'll do is I would just write my 2 there and the 3, and now start working on the variables that I have. Variables that I have, I've got x, y, and z. Right? X, y, and z. Here, the x's are the same. Divided powers of the same base. The base is x. What do you do to the exponent? You subtract the exponent. So x would be 4 minus 2. We are dividing here. We are not multiplying. Okay? Then let's get to y. Y, same base. Write the base once is y. Subtract the exponent, minus 4 minus 3. You see now we are getting deeper now, we are getting much complicated now. Things are getting complicated, not easy as we started. Where exponent of the numerator is bigger than the exponent of the denominator. But now it's a different story. Hence I'm saying you need to make sure that you understand how to work with your integers. Right? Then the last one I've got the z and the z. Dividing exponent of the same base. Write the base once. Subtract the exponent is minus 3. Minus 4, right? Then I have here, this I can just simply put it aside. Then I have x. 4 minus 2 is 2, all right? Let me just pull this thing, and it must just go up there. Then I must get now here to y. It's minus 4 minus 1 multiplied by minus 2, it will give you plus 3. Then the z here is minus 3 is minus 7. Okay? Now I have to simplify the y. The y is, I'm not done with the y. Then I've got x squared here. Then minus 4 plus 3, it will give you y is minus 1. The z is z minus 7. Positive exponents, you need to work with positive exponents, then I have 2 over 3 x squared. This one, it will go down there, it become positive. This one go down there, it become positive 7. Right? So the answer that I have here, if you have to write it nicely, if I have to write it nicely, is 2 over 3 x squared over y z to 7 power 7. This is the simplified form. Right, let's look at 29. It's the last exercise, 29. Number 29 is a 4m p to power 3, all divided by 3m squared and squared p to power 4. Right? Look at the coefficients there. This number, it's a 4, it's a 3. There's nothing that you can do with that one. You can just write it as it is. 4 over 3. You can simplify it, say 1/3. Yeah? Now, let's get to the variable. M, dividing powers of the same base m, we subtract the exponent. Is m4 minus 2. Then you get to n. N squared, n cubed divided by n squared, it will be n 3 minus 2. Then you get to p. Then p, you see, 3 minus 4. I did not say 4 minus 3. I said always I keep it that way. It's a law. Numerator, subtract denominator. Yeah? That's what I've done here. All of it. 4 over 3. M, 4 minus 2 is 2. Right? Then n, 3 minus 2, 1. I can write 1, I cannot write it, but it is very, you need to know that if you write 1, it looks like, no, you are not yet there with mathematics. N to power 1, you know there's a 1 there. I was just indicating to you there for the purpose of applying the law so that you don't get confused, you just write the 1. But if somebody has written you, I won't penalize the person that has written 1. But you need to grow as small mathematicians that you don't have to write it there. I know it's 1 there. Okay? Then here I've got p here. 3 minus 4 is minus 1. Yeah? Then I must write it as a positive integer. Then I'll have 4 squared n all divided by 3p. Remember, this is the negative. It must go to the denominator. This is p to negative 1, so it go to the denominator, it becomes positive. When it go up, it becomes negative. Okay. Right, boys and girls, this is all about the exponents. Please expect the exponents, a combination of the laws, whenever in a test. In other words, what I'm trying to say to you, practice all this law. Be perfect in each and every law that we have. Then you must get to an exercise where there's a combination of these laws. Then you'd know, for this one is this law, I must apply the law. For this one is this law, I must apply the law. That's exactly what one has to do. Thank you very much, boys and girls. I wish you all the best. I would really, really want you for you to be able to make it and to understand mathematics much better. Do not ignore to complete the activities that are in this book. Ne? For us, we've done exponents. There's a lot of activities that you have to complete. Then, really, when you do this, all activities, you shall have really practice mathematics. You know exactly how the rules are applied in exponents, and not necessarily in that topic. All other topics are covered in this book. As I said, when I get to your school, I would really like, even subject advisors, when they come to your school, they would want to see how well you have completed these activities. Please complete these activities. They will help you a lot. You will see in the long run, you will benefit from this book. Right? Teachers, as I've indicated to your learners, maybe most of you were listening, that it's very key that these books. Some of you have not distributed the book to the learners. Please, if you have not done that, you do it as quickly as possible. These books must be with the learners. Whenever they are at home, they need to practice. Give them work in these books. When they come back, you start marking the activities in the book. Thank you very much. I'll see you next time. Thank you, teachers. Thank you. Bye-bye.